Good evening, or whatever time it is with you. It is evening here in Chico, California. This is our second broadcast in an elementary series in universal geometry. The reason I use the exalted word universal is that we are indeed trying to build space in our minds so that we can try to match the space in our mind to the actual space of the universe. So far, that has not been done. And what has been done is to put lines into space. And so in our first lecture, we did exactly what science has been able to do with lines, which is all science is. Everything in science, from quantum mechanics to the Big Bang, anything in the Einstein field equation, Paul Dirac, Erwin Schrödinger, equations that cannot be understood and never will be understood because they do not describe cosmic space, but they get close, very close, because the universe is, of course, spherical, as we know as children. It's spherical. But how do we know that? That's what we discovered in our last lecture, is that we already know that it's spherical, but it is very important to prove that that's exactly what we see. Now, whether the universe exactly matches what we see, whoa, that's a deep philosophical question, isn't it? Not at all. We can prove what we see, and I'll show you how to do that. But in science, what's called science now, which we've had for 2,000 years, really picked up the pace in the last 200 years, you can see the advantage of using lines to build space. Because on Earth, you can fake it. You can fake that the universe is made of cubes. And we learned that in the last lecture, that that's exactly what science is built on. Cubes. Because you have one straight line. We built that. We found out how to do that. It's quite easy. But as soon as we went to draw the second line, we discovered that the universe is magical. This is very, very rarely pointed out. This is philosophical. That second line that you can draw with respect to the first one, if you think of the first one as horizontal, you can draw a second one at any angle, correct? But if you balance it, it's vertical, and that makes square space. That's extremely powerful. Has nothing to do with the universe exactly, as I'm about to show you, that's actually a huge mistake, but not for Earth. It's a mistake if you want to understand the universe, but nobody ever wanted to understand the universe for the simple reason that nobody could see it. We couldn't see the universe. And we still haven't seen the universe, and we never will. We will never see the universe. But what we can do is extend our minds to match the universe, whatever it is. But for that, you're going to need to encounter infinity. So to get started, picking up where we left off in the last lecture, the line has two infinities, doesn't it? Yes, it does. But the question is, are they the same infinity? Well, if you're drawing a line, they're not the same infinity, because the way we make the line for numbers, this is to make numbers on the line. Once you have the line, you have to have zero. Why do we have to have zero? So we'll have a place to start to measure straight ahead to get a distance that we call a centimeter, an inch, a mile, a light year, anything. Those are straight lines, but they're not straight lines. They're straight line segments. And that means it has to have a beginning, and that's always zero. It's always zero. It has to be. Why? Because of one. It's because of one. Because you can't put one on the line unless you have zero. If your intention is to measure distance, that's all science can do. That's all science has ever done, and that's all that Albert Einstein's four-line construction does, and I promised you that's where we would pick up in the next lecture. That's right now. So we found out that a straight line makes sense and it hits two infinities. Then we found out that if we use the magic that's built into us by DNA to see the perpendicular line, now you have flat space. And then, if you're clever, and this took a long time to figure out, you can draw a third line that's perpendicular to both lines. And so all three lines are perpendicular. Now, you know that, but it's extremely important in geometry to spell these things out. And never was it more important than right now, because that cannot possibly describe the universe. But what it does is it builds a grid that we can use on Earth for industrial science. From everything from building a wheelbarrow or building a pyramid, all the way to building rockets and computing the Big Bang, is done with straight lines. And that's all we've ever used. Why? Why? Because we're very young. We've only been around for about 6,000 years. Humankind does not go back more than 10,000 years. Before that, nobody knows what happened, unless you want to listen to some of my lectures over the summer. I'll tell you exactly when and how the Earth and the ecology came into existence. It's not from the Bible. It's from something far more powerful than the Bible. It's called reality. And science can penetrate reality. The Bible cannot do that. And neither can any wise man. And no wise man has ever tried. Because why? Because humans don't need to know about the universe. Humans need to know how to fix themselves. And that's why you have Jesus and the prophet and charlatans. The prophet and Jesus and other prophets, by definition, are not charlatans. But that's religion. I'm only showing you, you'll never need religion again, unless you're called to it. There are two paths to heaven. But this is the right one. You know why I can say that? Because I cannot say that about the Bible, or the prophet, or any religion. You know why? I can't prove it. But this I can prove. And that's the story of true science. And true science runs right parallel with any other kind of science. Modern science is technology. That runs on straight line logic. It's your straight line logic, 3D, that we've been using to the present day exclusively. It's the only geometry that's ever been used. But you see, a century ago, we discovered the universe. Okay, you already know that if you've been listening to my previous 270 lectures. But if you haven't, we're just going to pick up as if you had never heard any of my previous lectures. But if you're curious about anything that I just said, you can go back through the last half dozen lectures. I cover all of it. Okay, so what we want is to actually understand the universe through geometry. That cannot be done with straight lines, because the universe is spherical. And we're now going to prove that. This has never been done, by the way. So you're in a most extraordinary position to be listening to me right now. And I have to say me, because no one else has even thought of this. It's an incredibly difficult process that I'm now going to make easy for you. But I made a promise in the last lecture that we're going to expose the logic that Albert Einstein used to build SpaceTime. Now, if you're not sure what SpaceTime is, neither is anyone else, except it's the only geometry that's in use right now in cutting-edge science. So it is important whether it's understood or not. I'm going to show you how to understand SpaceTime, so you'll know everything about science right now that you want and need to know. You have to find it out for yourself. The scientists won't tell you. They can't. They don't know. But you can know, because you're listening to Anagalactic. So what we are going to do now is extend 3D, that's 3 stick space, 3 lines, line, 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 X, Y, Z. That's the only form of science that's ever existed, you understand, is lines. There's never been a geometry of the circle, and there's never been a geometry of the sphere. But if you want to understand the universe, which is why I am here, and that's what we're leading up to, you're going to have to understand the sphere. You're going to have to evolve past all the scientists. So this is how to do it. You have to be able to prove it, too. That's why I'm here. So you'll be able to prove it to yourself. So, we have the 3-stick system called 3D linear space. That cubifies space. Of course, that's ridiculous. Space is not made of cubes. But what it's good for is you can pretend to draw a sphere inside the cubic space. In the same way you can pretend to draw a circle inside of square space. The XY flat plane system permits you to draw a circle. The only problem is the circle doesn't match any of the lines. And so if you want to understand, like, planetary motion, you're going to need calculus. Because calculus will change the curve kind of into several linear numbers. And you know that from sine and cosine. Well, if you want to understand space-time, you're going to need 4-tensor calculus. That's extremely more difficult. And sine cosine is nobody's idea of a fun ride. Also, it's ineffective. Sine and cosine are illegal actions in the universe. You're not allowed to use sine and cosine in the universe. That's very little known. In fact, that would be completely rejected by anybody in the scientific industry. We see that's the problem. It's an industry now. They're not looking for truth, and they're not looking for understanding, and they don't want to know anything about the universe. These scientists that write the books, they don't care at all about knowing about the universe. They want to make money. And so that's what science is for now, is to make money. And if you want to make money, get the hell out of here. There is a small band of people at all times that want to know the truth. So let's explore how Albert Einstein got us to 4 stick space. You have the first line, which gives us linear separation called distance. That's all science can do. That's all science has ever done, is measure linear separation in space. Anything that curves, we just don't know what to do with it. We can't use it. But we can pretend with calculus. And that works on Earth. It will never work in reality. The Earth isn't quite real. We're able to fudge and fake things. Isn't that fun? Because it makes refrigerators and jets in your computer. That's from lying and cheating. It works. It's a gift of heaven. It's not lying and cheating. But if you're trying to understand the universe, you're going to need to understand Albert Einstein first, because he actually got us there. And this is how he did it. Albert was working on train schedules along with Henri Poincare in France. They were both very interested in train schedules. And the reason they were studying train schedules is they were very concerned with simultaneity. Now, you could put it the other way around. They were concerned with simultaneity because they were trying to solve the train scheduling problem. That's very difficult to do, and in fact, it's the same problem that you would have with geopositioning if you didn't have general and special relativity. Here's how Albert fixed everything in terms of simultaneity in the universe. He decided that time must be real, and nobody had ever thought that before in the entire history of the human race. Albert Einstein decided that he was going to make time into something that could be computed. Gee, he did it! He actually did it. But in order to do it, he had to turn space inside out so that no one could understand it. And then he had to use four-tensor calculus, which nobody can compute. So we got nowhere, except you got GPS. And that's all you got out of Albert Einstein's 4D space. GPS. It doesn't do anything else, except along the way, Albert figured out the most incredible insight into universal geometry that any human has ever found. And no one will ever teach you what that is. I will. And you're going to be able to name it before I'm done. You start with 3D space. That makes the entire universe all the way out to the Big Bang. It explains everything before God himself. They think. But that's all it is 3 lines that goes out to the cubic edge of space, and therefore the universe is an ice cube. Did you know that? Well, I hope you don't know it, but if you go to college and study calculus, that's all you're going to find out. Because the universe is a big ice cube that you'll never understand. And so you can save yourself $100,000 and 16 years of your life by listening to this lecture. Okay. He added a 4th line to space that's already filled. Because if you have a freezer filled with ice cubes, but you want to cram in an equivalent space of bricks, you can't. There's no room for the bricks. Well, Einstein took a ton of bricks and shoved it right into space, which is already full. It's already full of ice cubes. The universe is filled with ice cubes. According to what you'll learn in the universities, it is. The universe is filled with ice cubes. And there's no way to cram any more ice cubes in there. Well, Einstein just came along with a dump truck bigger than the whole universe, backed it up, and turned the whole pile of bricks onto the universe and crammed it into it. That's called SpaceTime. The space is the ice cubes. The time is the ton of bricks. And nobody has ever understood what Einstein actually did. I'm dramatizing it, and I hope you appreciate that. But if you have 3 lines, the horizontal, the vertical, and then to see the third one, you have to turn it sideways, and then another horizontal one. Right? Are you starting to see how ridiculous is our number system? These are our numbers. So, and they all converge at 0. So you have a 0 at the center of the universe. And then sticks that come out of it. But they don't go out diagonally. They don't go out in any other direction except 3 directions, which you could think of as 6 directions. If you're not doing diameters, you're using radii, then there's 2 going out from 0, 2 more going up and down from 0, then you have to turn it sideways, and 2 more going sideways. That's 6. They're called rays, but it's just garbage. You can't possibly compute universal space with those. But Einstein showed us a trick. And I studied this for quite a while, so you can take it from me. You are allowed to do this. He wasn't cheating, although it looks like he's just the most hideous mountebank that ever walked the earth. And there are some people who actually think that he's criminal. Ken Wheeler thinks that Albert Einstein is a criminal. Ken Wheeler, the famous magnetist. Well, magnetist? Yeah, right. Try reading his book. I like Ken Wheeler. Shout out to Ken. You're okay. But not in my class, you're not. Okay. So what he did, that is Albert, he figured this out because he saw that Minkowski had done it. You can take an imaginary, oh, wow. Doesn't your head hurt already? And you can't see it. That's why we're going to go through this quickly, so we can start over and get this right. Albert he got it. He just got it by cheating. He had no choice, so don't blame him. I don't. He's a permanent member of Anagalactic. And so far, there's only like 4 or 5 people that I've allowed into my organization. And Albert was the first. So don't you dare make fun of him. I will, though. I have the right to make fun of Albert. It's because I'm way ahead of him. And so will you be when you're done with this lecture. So he decided that he was going to do what Minkowski did. And Minkowski is the guy who invented SpaceTime. It was not Albert. It was Minkowski. And another man named Lawrence also got it. But the reason why neither one of these guys felt cheated by Albert, because Albert, he figured out how to put time into it. And that's ridiculous. But it's not ridiculous. But it is ridiculous. But it's not ridiculous. Get used to that. That's called superpositional state logic. And Albert Einstein is one of the men who discovered quantum mechanics. Don't forget that. And Albert Einstein was according to himself, far more interested in quantum mechanics than he ever was in relativity. Relativity is actually a fairly simple trick. You have to figure out how to measure simultaneity. Well, you can't. You can't measure simultaneity. Well, Albert said he's not settling for that. He decided he's going to measure simultaneity. And so he just said, just right off the bat, I'm going to take time and I'm going to put time on a line. Well, that's absurd. You can't, it's not spatial. He said, yes, but I'm going to pretend that it's spatial. You might think, just don't even give him the time of day. That's actually a pretty good pun because it has the word time in it. Here's what he did. He said, because he also knew there was such a thing as 4D space that had just been discovered within a century before Albert. Nobody in the history of the human race had ever thought of 4 dimensions. It's because you'd be out of your mind to imagine 4 dimensions. Well, then a guy named Bolyai discovered it. And then another guy in Russia discovered it also. And then Gauss discovered it. And then everybody discovered it. And then James Clerk Maxwell, in one of his many formulations of electrodynamics, there have been 4 major formulations of the definition of light, electrodynamics. But the one that uses a 4D system called quaternion algebra, that's the right one. That's the correct use of a 4 positive system for lines. These are all lines, okay? And then Minkowski figured out some more things with 4 lines. And then Albert took it to town. He decided that the 4th line is time, but it's spatial. And that's called space-time. And that has dominated science for a century. Exactly a century. Is we've used nothing but space-time. A 4-line system, and here's what I want you to know about it. The 4th line, which is time, is negative. Okay? Negative. That means space is going positive in all 3 directions, but time is going backwards. In order to make that, well, this does work, but he had to do a second trick. He's allowed to do that, by the way. It works. But how could that be useful? Because it's ridiculous. It's because not only is it negative, it's imaginary. If it were just imaginary, it would be BS. If it were just negative, it would be BS. But because it's negative and it's imaginary, now you can use complex numbers. Only Albert went one step better. And I could tell you what it's called, but I don't want this to be too confusing because we're trying to get to the good part, which is what I discovered this year, actually in 2022. So what that does is it turns spherical space inside out. Now, don't forget, gravity is a spherical phenomenon. It's not hyperbolic. It's spherical. A child knows that. Everybody knows that. But Albert said, well, we need time in there, and so he had to turn it inside out. That's called hyperbolic space. It's impossible to visualize unless you study it for years. I did so, and I have visualized it. It hurts. It hurts to visualize that. But then to add insult to injury, in order to do any computations, and the only reason this was done was to make computations. It was not to understand Dick. It was not to understand anything at all. And actually, the only person who understood anything about this was Albert Einstein. Nobody else has ever understood this. And it's impossible to understand it until I came along. And now I'll tell you how you can understand it. It's just about the way I just told you. You turn space inside out. Inside out. And that does several insane things. But what it allows you to do is measure simultaneity at any distance you want. And if you're attracted by that, you're going to love the Alice and Bob experiments. This has no use whatsoever. Space-time is useless, except, and here's the key, when Albert made space the fourth vector, I always say vector, that's axis. A vector goes in one direction, an axis has no direction. I should say axis. So the universe is a three-axis system. That's all science has ever used. Albert said, well, I'm stuck with that, but I need to have time, so I have simultaneity, but it's also in space. So I will say, and here's his breakthrough, they're perpendicular. They're perpendicular. Space and time are perpendicular. I have proved that he was right in that. And that's the only thing that Albert was correct about. Space and time are in fact orthogonal. But if you can visualize that in your mind, it's because you're smarter than I am. Because no, you can't, but I can. And now I'm going to show you how you can see that as well. And if you do, you will be only the third person to have ever seen that. Albert Einstein was the first, I was the second, and you'll be the third. To understand the secret of space-time. But that's not going to help us. And all you do is just be a pompous stuffed shirt like I am, and just get away with bragging about bullshit that nobody's ever going to believe or care about. No, what you want to do in science is get the truth. Now, I just told you the truth of what Albert Einstein achieved. He did not create hyperbolic space for gravity. That's not true. He did not do that. He did not invent space-time. That's a figment of his imagination. But he was able to make two mistakes, and he knew what he was doing, or he never could have done this by accident. He actually worked on it for close to 10 years, between 1905 and 1915. That's from special relativity, which has nothing to do with gravity, to general relativity, which is for cosmic space. It's the formula for gravity inside out. It's inside out in order to get simultaneity in gravity space. That has led to an absolute deadly dead end, as everyone knows now, but nobody can fix it. Here's how to fix it. Erase all that. There's no such thing as space-time. But remember when we created the line and then erased it? The reason we drew the line first to create universal space was to find the center. And then we didn't need the line anymore. What we got from Albert Einstein is not space-time. You can erase that. But there's something left that we did not have before. The orthogonality between space and time. That is the secret of the universe. But in order to make use of it, you have to see it in real space. And real space has several terms, and real space is not one of them. I just made that up. But any word that I use will be flawed, and you'd have to invent a brand new word for actual real space, universal space, that actually is the real space. It's not lines. And you should know that without proving it. Oh, but in science is brutal. You have to prove it, even though everyone knows it. Everyone knows that the universe is not made of lines. Although, yeah, well, Dr. Sabine Hossenfelder takes care of those who disagree with me. If anyone disagrees with what I say the universe is, I sick Dr. Sabine on them. And she just smooshes them with cream pies. And then they just peel the cream out of their eyes, go right to the bank and flip her off. They're trying to flip me off. I love Dr. Sabine Hossenfelder. She's going to take the flak. I'm going to just sail right through while they're firing at her. I love her. She's married. I don't mean love that way. But I love her as a scientist because she's protecting me. So now we go back to the beginning, and we're going to finish this in only 8 minutes. So we keep this to 40 minutes. We go back to the universe empty. We got the point. We got the edge. We put infinity over 1 at the edge. We put 1 over infinity at the center and generate the number 1 by multiplying them. That is the surface of the universe. The radial line that comes out from the surface of the universe is the integral line, since it's all the lines that come out from the center. But there's a trick. There's no center to this sphere, because we're used to seeing in straight lines, and so that if we were at the center looking out from the center in all directions, like some hideous transdimensional spider, and we're just looking in all directions at once, we're looking through the surface of the sphere at a 180-degree angle. The universe uses a 90-degree angle. That's what Albert Einstein proved. So as space goes out in shells, and Max Planck discovered that that's true. So space goes out in shells from the surface of the sphere, but nothing is inside. It's 1 over infinity inside. That's imaginary. You can't touch it. And that's the infinitesimal. But the surface is the universe itself, but not space. What is it? $1 million question. You got the surface. It's the number 1, which is a sphere. Nothing inside. Just the sphere. It's the number 1. Max Planck said the next concentric sphere is 2, with nothing in between. That's frequency. Where did wavelength go? It's 1/2. The reciprocal of 2. But it doesn't go in. That would be 180 degrees. It goes sideways on the ring. And now you know what space-time actually is. It's the orthogonality on the sphere with space. And that means the sphere is time. That's going to be the electron. You might ask, what is the proton? Well, that's a good question. Let's think for a moment. Look at the electron with me. I know this isn't geometry, but we're going to jump ahead so you're curious and you'll start to send me all the money I want. I'll never ask for money. But I want you to watch all of these lectures from now until the solstice. because I'll be dead either during that time or shortly thereafter, is my belief. And so I want you to get this before I die. One of the universes, and think of universe as the actual universe, not in the mind, the real universe. There are two of them, but they overlap. One of them you can see and the other one you cannot. The one you can see is spinning in. And that's absolutely true, and a moment's thought will convince you of that. What are atoms doing? They're spinning in. Nothing goes out from an atom. Ooh, yes, something every now and then goes out from an atom. It's called a photon. This is actually a big problem. How come the Bohr atomic shell system holds together? Because it should lose energy. Because even planets going around the sun lose energy. But electrons never do. Oh yes, they do lose energy. You know what happens when they lose energy? Light. Light goes out. Nothing else in the whole universe goes out. Light goes out. What goes in? Space. Space goes in. Yeah! Everything in the universe is being sucked in by the protons. You think about that for a second. How come the proton is at the center of the atom? It's because it's the space particle. Well, what does that make the electron? Well, obviously the energy particle. Well, what's energy? What's pure motion? Oh my God, what does that mean? Time. Time! Space is not time. Right? Well, why do we keep saying the curvature of space-time? Sticks. Albert Einstein took those 4 sticks and twisted them into a hyperbolic pretzel. And that's called the curvature of space-time. Every time you see that term, if it's in a book, scratch it out with a nasty red pen. There's no such thing as the curvature of space-time. And we're going to prove that. I already have. I'm just going to let you in on it. But what is curved? Space is. Yeah, in one universe it is, space, and there are 2 universes. You're going to have to get used to that. One of them you can see, and it's there at all times, you just can't see it. It's time-space. The one we can see is space-time. Didn't I just contradict myself? No. There is such a thing as space-time. It's just not curved. Only space is curved. What about time? It's linear. Or you can do it the other way around. You can linearize time and then space is curved. That's gravity. Or you can linearize space and let time curve. That's energy. Also called light. Also called the electron. It's called motion. It's called time. None of those are spatial. And neither is the electron. That's why it orbits around the proton. It's because the proton is not only bending space, it is space. And the center of the proton is 1. And what's inside of it is 1 over infinity. Now look at the electron. It's spinning, right? Where's it spinning? Nowhere. It's not spinning anywhere. It's time itself. If you start to look at it that way, it will all make sense. We're going to make it numeric. But before we make it numeric, we're going to make it geometric. You just got a head start. And that's 40 minutes. I'm going to try to get this out as fast as I can, but time, space, and space-time are reciprocal. And the reason that we can see the universe is because everything is spinning in this direction. And when it's spinning in this direction, in space-time, it's going in. But there is a contraspin, according to Emmy Noether. Because angular momentum is spin, it's rotation. The whole universe is rotating. But only time can rotate. But in the other universe that's reciprocal with this one that we cannot see, in one space is rotating, in the other one time is rotating, but they're always both rotating, and they're always perpendicular. Why are these perpendicular? Albert says so. Max Planck says so. I say so. Can you see it? No. Not until I show you. That's 40 minutes. Stay tuned. Ana Galactic will be right back with the secret of the universe that answers the quantum paradox and addresses the Big Bang and corrects it, and gives the proper geometry of the supermassive black hole that explains the birth of galaxies, both elliptical and spiral. You think I'm kidding? Go find someone else to listen to. Now tune in. We'll be right back.